Speakers. We got Cooper Guns. That's where'd he go? He was right there. He's over there spreading out shirts. He's a developer evangelist, so he can talk to you about the state of the art of the system and answer any kind of developer-oriented questions. And he's going to talk about Hedera and Hashgraph in general. And then we're going to have a couple of guest speakers from Lone Star Data. So we got the CTO, Nathan, and their developer, or CEO, Nathan, and their CTO, Sam York. And they're going to talk to you about their startup and their company and how they're applying Hedera as a distributed ledger technology. All right, so before we get blowing and going on that, I had a couple of just admin notes. First of all, hopefully people saw on the notes that parking, you can get validation from the nice young lady up front. We'll give you a parking validation if you park downstairs for $7 instead of $30. Take all the pizza and beer. Don't want to have to take any home with me, so please help yourself throughout the meeting. We also have some shirts and some stickers that they're spreading out in the back, so feel free to grab something on your way out. And then the other thing I wanted to say is our next meetup is going to be 19 November. And I'm working with a gentleman called Justin who is building a .NET wrapper around the SDK to have a Zoom teleconference with us and a little bit more of a technical exchange talking about his version of the SDK. So that's what we have on the agenda for November. All right, so that's going to do it for announcements for us, but we're not going to go around the room and have everybody introduce each other because that'll take up a lot of time. But we do have a lot of blockchain activity and distributed ledger technology activity here in Austin. So I wanted to see if there's anybody in the audience that has a shout out or wants to make an announcement or anything like that about any other events. Anyone?
It's the time to show your project.
All right, yeah.
I just wanted to shout out to Lone Star Data Solutions, and I know they're going to talk later, but very good guys.
Yeah.
So just shouting them out.
I would like to second this shout out.
Right on. Right on. We got shout outs on top of shout outs. That's awesome. Peter, you want to say anything about the collective?
Sure. I'm not sure whether everyone. Oh, sorry. Hey, not sure everyone here is aware there's something like 120 blockchain-related companies with a presence here in Austin, and so that's already quite a few. If you want to know more about them, there's a website called austinblockchaincollective.com, and if you go there, you can find out more about them, and you can find my email and send me an email and say hi. But there's quite a lot of information on there, so we run our own meetups and try and get some of the companies here collaborating together. And really happy to have Al in this meetup as part of the community now. Thanks. Next meetup's on Monday. That's actually going to be focusing on security tokens. We cover quite a few different topics in our meetups, so it could be enterprise blockchain 1 month and cryptocurrencies the next, so feel free to come along.
All right, thanks a lot. Anyone else? All right, well, without further ado, we'll go ahead and get started and invite our Hedera developer evangelist, Cooper Guns, to come up and tell us all about developer evangelism.
Oh, yes. Thank you for the kind introduction. Can everyone hear me okay? Is this cool? Don't want to yell in the co-working space. And so yeah, I work at Hedera Hashgraph. Who here is like kind of familiar or would say that they know what we do? Everyone? Maybe, sort of. Okay, cool. Almost everyone. But I'm mostly here today to talk about exploring use cases. I'm going to give you a background about what we do, kind of our goals as a company, and some of the things we kind of set out to solve in the market. But I'm a developer evangelist. You can find me on Twitter. Email me, it's just cooper@hedera.com. I'm an easy guy to get a hold of. So if you have any questions, obviously I'll be here too. But Hedera really was set out to solve kind of these 4 requirements for enterprise adoption of public networks: performance, security, stability, and governance. And so Hedera is basically, our goal is to systematically address these 4 issues And then hopefully, and through our governing council, enterprises around the world will feel comfortable building on public networks. And so if we're able to fundamentally address these kind of 4 tenets of Hedera, or the 4 problems that we're setting out to solve, Hedera will become, and already is, kind of the 3rd generation public distributed network. We can handle orders of magnitudes of more transactions per second than traditional blockchain alternatives. Most traditional blockchains don't have any type of guaranteed finality, so there's no point in time that you really know your transaction gets included. And our transaction fees are like fractions of the cost of other platforms. Kind of got messed up a little bit on the slide, but basically Hashgraph is an underlying consensus mechanism. It is a data structure and consensus algorithm that was invented by Dr. Lehman Baird. It is not a traditional blockchain, but Hashgraph is an alternative to the proof of work that is used in traditional blockchains. Hashgraph uses a directed acyclic graph, also called a DAG, and then kind of 2 novel inventions on top of that DAG called virtual voting and gossip about gossip. If anyone's interested in the specifics of how these things work, I'd happy to talk about them kind of at length after the presentation. It does get pretty technical pretty quickly. But Hedera is the public network that anyone can use, anyone can read from, anyone can write from, built on this Hashgraph consensus algorithm. It's live right now, you can use it, and we currently support over 10,000 cryptocurrency transactions per second. We're actually averaging a finality time of about 1.9 seconds, so it's actually under this estimate. And it's formally proven to be what's called asynchronous Byzantine fault tolerant, which is the kind of gold standard for security in distributed systems. You can look up ABFT. It's basically your traditional Byzantine fault tolerance, but with no assumptions about network partitions or how long it might take to send a message over the network. So there's no like, if this doesn't happen in 10 seconds, or if the network doesn't connect in 10 seconds, this is invalid. You could have an infinite long network partition, and it'll still run properly. And then for those that aren't really familiar with blockchains, yeah, no guaranteed finality, no point in time that you're like, oh, I do have my money. Just after a certain point, you're like, oh, I'm confident enough that no one's going to attack Bitcoin. Most blockchains are actually permanently immutable, so we'll talk about this later. If you happen to be a business and you accidentally upload like PII or any type of information that's later deemed illegal to store, you will forever be kind of upholden to the rights and the responsibilities of uploading that data. So if you as a company upload data to Ethereum, if eventually it's illegal to have published that data, there's no really clear answers for what you do as a business there. And then, yeah, it's not really efficient, and no blockchains really scale beyond, 100, maybe 1,000 transactions per second. And so just to give you a picture of how this kind of works, the Hashgraph consensus algorithm sits at the bottom of the stack, so it's actually the underlying kind of the sweet sauce or the secret sauce. On top of the Hashgraph consensus algorithm, we have 4 services that we've built. I don't know if it's really hard to see these slides or not. But we have a cryptocurrency service, we have a smart contract service, we do files, and then we have a newly announced consensus service. And so these are just 4 different ways that developers can use our APIs to actually build on this Hashgraph-based consensus. And so we make it really easy to use these things, we make it abstracted away, we build tools, so it's a really nice environment for developers to build on. And you can see off to the right, we have like the actual Hedera Governing Council. And so the Hedera Governing Council is responsible for this kind of bottom of the stack. So they oversee the Hashgraph consensus algorithm. They oversee the development of the services. They oversee kind of everything that happens at that bottom. And then anything can be built on top of that kind of bottom of the stack, where you have third-party applications that can be in any type of market, any type of geography. They can be logistics, retail, gaming. They can be public, private companies. They can be one individual person hacking in their basement, or they could be the largest kind of company in the world. And so just to talk a little bit more about the Hedera Governing Council, the Hedera Governing Council is our direct response to the stability and the governance questions that I kind of posed earlier. So how can we create a stable enough environment that large enterprises themselves feel comfortable enough to build core services on? And so the Hedera Governing Council is consistent of up to 39 organizations all around the world. They're segmented by geographies and markets. So we'll actually only allow, X number of companies that are telecoms to be on the Governing Council, or X number of people in like the security industry to be on the council, so that they don't have too much influence or power. On top of that, they're also term limited, so they'll only be able to serve a 3-year term. They'll only be on the governing council for 3 years, but they can serve 2 terms, so they can serve a maximum of 6 years kind of controlling and running the network. But unlike Bitcoin and unlike some of these other protocols where you have the founders or the core development team or the core researchers contributing to that or controlling that forever, basically however long Vitalik wants to run Ethereum, he can. We can guarantee that these kind of people won't be able to control it longer than 6 years. So these governing council members actually need to come to a supermajority agreement to change things. So 2/3 plus one of them would have to agree to make a lot of the critical decisions. Some of the more critical decisions actually require a unanimous agreement. So this is our answer to, if you're curious about kind of who am I going to talk to if things go wrong? If I invest millions of dollars into building on Ethereum and Ethereum standards change or my application breaks, who is kind of responsible for that? Who is my wasted investment? And so the governing council is basically attempting to provide a stable environment where if like an IBM who's on our governing council wanted to build on a public network, they know for a fact that these companies are investing in it themselves and would be very kind of disillusioned to doing something not in their best interest. But basically, these companies are able to make decisions about what goes on with the platform. So actually what the platform can do, like what services are available. They actually make the decisions of when we release new services or when we kind of prioritize things. Things like quantum encryption, like how concerned are we about post-quantum signatures, would be top-down decisions from the governing council. They come up with our fee model and basically the way that we charge applications and generate revenue. They're also responsible for managing our treasury and kind of allocating and distributing funds. But we also have strong and enterprise-led governance, and so through a variety of technical controls and legal controls, Hedera actually is a platform that will never fork. This is one of the most unique things probably about the Hedera platform. So if you're building an application, say you're building like tokenized assets on a platform that can fork, as soon as you have 2 forks of that, someone could potentially double spend that token, or there's actually, you have to have a governance decision of which of those forks do you kind of pick up and choose to support. And so not allowing forks is actually one of the major ways that Hedera enables enterprises to feel comfortable with the environment that they're building in. They only have to deal with one copy of their users' data. There's only one network that's the source of truth. You don't really have to debate which one to pick up and choose, which is a really nice thing. But because this is such like a kind of important role, they have strong commitments to the network, they have strong kind of responsibilities, there's so much riding on these companies. We're really excited that there's actually so many kind of huge, really well-respected and well-known companies already on the Hedera Governing Council. And so these are actually the first, these are 9. There's also the additional of Swirlds, who's actually the creator of the Hashgraph consensus algorithm. But these are the 9 companies that are actively governing and running the Hedera Hashgraph network. They make all the decisions about what we do, when we release things, and our new products. And so these are some of the biggest companies, from different market segments, from telecom to pure technology plays to, Air Force or airlines. So we're really happy that these companies have kind of joined on board and are co-owners of the Hedera network. But now that I've talked a bit about like kind of the stability and the governance of the network, I'm going to talk about what you can actually do on the network, the interesting parts, how it kind of got into shape is one thing, but what you can build on it and the applications that you could build companies with is much more interesting in my opinion. So Hedera's cryptocurrency service, basically like every other network in the world, you actually use this cryptocurrency to pay your transaction fees. So whether you're sending someone cryptocurrency, whether you're deploying a smart contract or adding to a file, you're going to be paying a tiny bit of the native cryptocurrency called HBAR. So we can handle over 10,000 HBAR transactions per second, and you'll get finality in that 2 to 7 second range. This is all pre-sharding, so 10,000 transactions per second in one shard. Hedera is built from the ground up to shard, so you can handle hundreds of thousands or millions of transactions a second. And then it's also a security mechanism. So back before I was kind of talking about how Hashgraph works, it's built basically on a gossip protocol, which is how information is spread throughout the computers. And then once that information is spread, we use a virtual voting protocol to kind of determine the consensus on that information. And in this virtual voting protocol, the vote or the weight of your vote is actually dependent on how much HBAR you hold or how much HBAR that node has. So HBAR, how much HBAR that node has is actively involved in kind of the weight and the security of that node. It's very analogous to like Cosmos or Tendermint and all these other kind of proof of stake algorithms. Basically, one token equals one vote, and that's going to be used in kind of the coordination of how much influence your computer has in the consensus. Hedera has a file service, which is pretty unique. So it's basically a way that you can get off-ledger data onto the network. So one of the largest kind of connectivity problems is how do we have, blockchains can really only know about the data that's on the blockchain. And so with a built-in kind of file service, you can actually anchor or point to off-ledger data and really in a transparent way. You're probably not going to want to store like a whole movie or a whole video on Hedera because you have 100% data replication. Like every computer would have to store that 10 gigabytes of a video. But every computer could actually store a hash to that video somewhere with like a checksum, making sure that it's actually the right file that it's supposed to be. And so it's a much easier way to get off-ledger data onto the network for you to use. But it's also, because you do have that 100% data replication, it's really secure. So if you need to know that this file is there and it's the same file that was uploaded, you can actually prove that. And because Hashgraph does provide consensus timestamps that are accurate within milliseconds, you know when that file was actually uploaded to the network and you can verify that it was there. So that once you have this kind of transparent file system where you can prove to other people that you uploaded a file or had up contents on the network at a given time, there's a lot of interesting business models that you can do with that transparency. One of the unique things about Hedera actually though is that we do have what's called selective immutability. So like other blockchains, that problem where I said that after you upload data to that network, it's there forever. Some people see that as a pro, that's the point of the thing. Some enterprises or companies may say, we can't build on this because it's there forever. Hedera has what's called a revocation service. So when you define a file or upload a file, you can actually attach keys to it that have the ability to modify or update that file. So if I upload a file to the network, I can say me and everyone else in this consortium has the rights to edit this file. It would take a 100% sign off from everyone else in this consortium to edit this file. And so we have things like multi-sig or threshold keys that do that in a transparent way. So when you upload that file, you could see all the keys that would have to sign off on a transaction to remove it. So some interesting models with revocation and what we call selective immutability. Sorry, talking a lot really fast, kind of hoping to get to the use cases and the interesting things. Yeah, happy to take questions too. This doesn't have to be super formal.
So when you revoke credentials,
yeah.
Let's say I had a certificate of my work, an insurance where
Yeah.
and you get a revoke on there, it expires.
Yeah.
Can you see that the certificate existed at one point in time, or is it just because you guys have a single state, is it just gone forever?
Yeah, so that's a good question. It just depends kind of the model that you would want to use. So you could actually just update that file rather than revoke it. So you could say, this file is the current state of truth. Any of these parties can write to it, whether it's me or the DMV that's revoking my certification. Basically, you could say that the last log written to this file is the accurate status of that. So that's not really using the revocation service, but you'd be able to prove what the current status is. Optionally, though, if you did want to revoke it and actually remove it from the network so it's no longer there, you could submit that transaction to Hedera, and then you'd be able to persist that history in our mirror network. So you'd actually be able to prove at one point that this transaction went through that added it, and then you'd be able to prove at a later date that there was another transaction that went through that revoked it. Does that answer your question? And then basically you would have, there's some interesting legal problems about the mirror nodes hosting that data after it's been revoked, which we could talk about after. But yeah, so that's basically how the model would work, is you'd have two transactions that were validly signed from the supermajority of the network. And then you could send basically, here's a transaction hash to the first upload of that credential, here's the transaction hash to when it was revoked. Is that?
Yeah.
Yeah. I like the questions too. It's good to. Is it okay if we do questions in the middle? Is that okay with you? Yeah. Later? Okay. If there's any you can save, we can do after. But if there's something about the smart contracts or about the files, happy to answer it. And yeah.
So a second ago you said something about there being interesting business models that could come about as a result of knowing that the moment that a file was created.
Yeah.
Can you give an example
Yeah, absolutely. Just logging security information or as kind of like a fault redundancy. So if you actually don't trust, like I used to go to university, we use Dropbox, or we use something, it goes down all the time. We don't trust that this network, whether like say you're working at like, you don't trust whatever you're trying to upload it to. You could upload it also to Hedera as an additional redundancy to prove that you did try to upload it. And so that's just one example where if you did say like you have two bits of data, you're worried about one being hacked or altered, and you want the permanent truth, you could submit it to two different places. You could put it on the Hedera network, and then you could submit it to the centralized service, and then you could cross-reference and make sure that they're actually still the same data. So that once you submit that data, it's not tampered with or altered after, it's in this closed silo. So it's just providing transparency to business data or files that you want to upload. Is that kind of what you're looking for?
Excuse my ignorance.
No, not at all. It's all new stuff. No one knows anything here.
Back at that H-bar thing, you
Yeah.
were saying something about, like, there's weighted,
Yeah, it's a proof of stake algorithm.
yeah, so, who gets to create the H-bars, and how do they get created, and how does that work with the, like,
It's a good question.
like, the local services that you want to create, so, like, have 5 computers, have like a Hashgraph together?
Yeah. So Hedera is the public network. Like, so anyone can really run the Hedera software eventually. But the Hedera Governing Council created those tokens. So these companies and this entity that runs Hedera minted 50 billion tokens that are native to the protocol and kind of intrinsic to how the protocol works. So Hedera is a public network, like there's only one of them. You could spin up a private version of Hashgraph where if you only wanted to use it with like 5 computers, and if you wanted to know those 5 computers or whatever, like you could do that too. But Hedera is the public network where like the amount of computers you have doesn't matter. It's how many tokens you hold. Does that make sense? So there's a bunch of tokens out there that are currently managed by this Hedera Governing Council.
Can you buy them from you?
You can buy them from exchanges or other places that you can buy cryptocurrency. Like HBAR is a publicly traded cryptocurrency, just like you can buy Bitcoin. You can go buy HBAR on Binance or wherever you want. This isn't financial advice, though.
Do you think about like proof of work versus like mine nodes versus like proof of stake versus like capitals?
I'm not sure exactly what he's asking.
I kind of know what the next speakers are doing.
Yeah.
And now I'm confused about how the H-bars play into there.
Yeah, I'll get to it too. I'm still kind of talking about what like is available to use rather than how an end application would use it. Got another question?
So that's super great. So
Not at all.
I love the idea of like a public governing council.
Yeah.
How many would you expect to be sitting on that council, and then how would you, particularly for decisions that would be unanimous? I would
Yeah.
assume that a lot of the companies would have differing interests.
Yeah.
And how to balance, like the ideal of having a unanimous vote with corporate interests that might not want to vote the same way.
Yeah, it's super tough. So the answer to the first question is how many entities will eventually be on the governing council? It's up to 39. There's currently 10. It'll only be up to 39 on a rolling basis, so it won't just be 39. Like it'll be constantly coming and going. So like we can't guarantee there'll always be 39 on a given day. And if you read the LLC agreement that's publicly available, they have the right to leave whenever they want. So like there's nothing preventing them from leaving on any given day other than the fact that they genuinely want to be there.
You have the right to kick them off.
I believe they unanimously would have to vote someone off, but you can read our public LLC agreement. Like the literal legal document that they sign is on our website.
Cool.
And then to answer your second question, that's kind of the point, is that they might have conflicting opinions. And if you have something that's so important, like minting more than 50 billion tokens, you really do want all of them to agree. Like if they don't all agree, then maybe it's not that great of a proposal. I don't know exactly what the threshold and like what requires a 2/3 plus 1 versus what requires a unanimous decision. But we do release all the minutes from those meetings, and you can read those as well and hear what was discussed and see what use cases the council members are looking into and why they're there. But I'm going to hopefully answer some of these questions now that I am hearing them, and we'll revisit at the end, if that's okay. One more?
Yeah, the governing council, we all know that Libra had a similar
Yeah.
model, and some of these members have left now.
Yeah, well, Libra's members were actually not on their council. So when Libra first announced their members, they were all letters of intent. So those were companies that planned to join the Libra Association. They actually, I believe they joined this week, was the first members. I believe 5 members actually joined the Libra Association officially. I don't know if they've paid, I think Libra requires a $10 million deposit. But so like Libra currently has 5, we actually have 10. We could have chosen to announce LOIs and whenever we think a company wants to join our council, but Hedera is not going to announce anyone until they're legally part of Hedera.
I was just curious if maybe one of the 9 have left.
Hedera, no one's left. These are all active members. No one has left. And we did run a full-page ad in the Wall Street Journal. So Mance Harmon, our CEO, met with David Marcus in 2017 before Facebook announced Libra, basically pitched him our whole governing council concept, saying this is why you need strong enterprise governance, this is why it's important. You can look that up as well. There's a lot of good journalism about it. But yeah, so Hedera also supports smart contracts, so we can run any of the Solidity you're currently running on Ethereum or anything on these other networks. Unlike Ethereum or some of these other networks where you can actually pay more gas to be included earlier in history, Hedera doesn't allow that. So basically you're always going to pay the same fee. That fee is going to be fair, it's going to be consistent with everyone else, and you can't bribe basically the nodes to say pick my transaction over another. On top of that, one of the ways that we do enterprise-friendly features for smart contracts is, like I said, with multi-sig keys, where you can have a smart contract, and when you deploy that smart contract, you can define the administrative keys, and you can say that we have a consortium of 12 different companies, we're all running this smart contract, and you would need all 12 of us to sign off to actually stop or edit this smart contract. And so there's interesting use cases here, where it's not like the full kind of decentralized vision of Bitcoin or Ethereum and some of these things, but if you're looking at companies that actually want to be running core services on blockchains, things like this where you could have them collectively agree, say, hey, this is a huge security bug, we need to pause or pull this contract, and have them do that in a transparent way that's not controlled by one party, no one has inherent counterparty risk. This is a unique way to enable that. But we also have a 4th service that we kind of announced a couple months ago. It's the Hedera Consensus Service. We actually have a whole white paper just about it. It was co-authored by Dr. Lehman Baird, who invented Hashgraph, Brian Gross, who's a principal product manager at IBM, and who's currently on the Hedera Governing Council. And then Donald Thibault also co-wrote it as well. Looks like some of my links kind of got messed up, but you can go download it at /consensus. It's a good white paper. But the consensus service actually basically lays out a way that you can build with the native performance of Hashgraph. So our cryptocurrency can handle tens of thousands of transactions a second. File service and smart contracts are fundamentally slower, somewhere in the 10 to 100,000 or 10 to 100 range, not thousands, not thousands. But the consensus service actually does give you that throughput, that 10,000 plus TPS, and you can actually use that consensus service as the ordering mechanism in in a Hyperledger Fabric deployment or in a different type of centralized database or centralized provider. So basically, you can have this architecture where you have a hybrid model where your actually important decentralization pieces, the actual transaction ordering and the transaction history, goes on with the security of the whole public Hedera network. But after those transactions have been come to consensus and you have that order, you can take them and actually use them basically as the queue or as the consensus in your Fabric deployment. And so this way, you can actually have a Fabric deployment that has all of the trust and security of the Hedera network, but it's orders of magnitude faster than existing Fabric deployments. You actually use this hybrid model in a really interesting way. So we were really happy that IBM co-wrote this paper, and we'll have integrations with both Fabric that are open source and hopefully IBM's blockchain platform natively, enabling this for enterprises. But there's an amazing number of things that you can do. It's kind of like an alternative or the inverse of what other second layer scaling solutions are doing. Other second layer scaling solutions are trying to basically get how do we process all these transactions in a blockchain and then settle those transactions into the main chain. The consensus service is asking how can we process all these transactions and then process the results of those on a side chain or a second layer solution. So it's really kind of flipping the head on scalability and things in that way. But so now you kind of know the services or what features, all those 4 services are available via our APIs, but what actually makes sense to build on Hedera, why would you build on Hedera versus something else? So if you need 10,000 plus cryptocurrency or consensus transactions per second, if you're trying to scale your Fabric deployment, this an easy win. If you do need 10 plus transactions per second for smart contracts and file services and be able to have all the security that Hedera has for you there, but you can have, we will have orders of magnitude more than this. They're currently throttled, so we're just basically supporting the minimum number of files or smart contracts we think we need right now, just to be safe and make sure everything works properly, because we just launched like a month ago. But we're systematically rolling that out and kind of improving our throughput there. We've seen hundreds in tests and all that stuff, so not too concerned about scaling that as well. If you need low latency and finality, so if you have something where you're actually basically operating a point of sale system, or you need to confirm within a few seconds that sale went through and you need that instant confirmation, it doesn't make sense to do on a network that really doesn't provide finality. All of our fees are set in US dollars, so actually the price that HBAR is and the price that HBAR fluctuates isn't going to change how much it charges you to run your application. So if you're saying it'll cost me $100 a month to run with 10 users, you can actually plan your business out months or years in advance and know how much you need to charge to actually have a sustainable business model, which really isn't an option on some of these other networks where you don't know what the gas fee is going to be day to day or minute to minute. Like I said, we have administrative permissions where you can have consortiums or multi-sig keys attached to different files or accounts or smart contracts that does provide enterprise flexibility. Similarly with claims and revocations. Those are all things that you don't have to use. You can use them if you want. If you want it to be there forever, you can do that. We just give you the choice. One of the unique things that Hedera does as well that's not really talked about is that you can actually set signatures that are required to sign off on transactions incoming to your account. So like if you are a multi-billion-dollar company and you're dealing with US economic sanctions and people from Iran can't send you money, how do you prove that no one's sending money to your Ethereum address? You really can't. Like they'll send your money there and you might have to try to get rid of it afterwards, or I really don't know what happens. But with Hedera, you can say, I'm a big company, I'm only doing business with these 4 other parties, we all have like an outstanding legal agreement, and all 4 of these parties would have to sign off any transaction for money to actually get into my account. So it's a really unique thing. Multi-sig and threshold keys, so basically your key can be any type of arbitrarily deep or arbitrarily complex signature schema. So you could actually build keys or accounts that kind of map to real life use cases where your board of directors would all have to sign off on something to move funds out of treasury, or you'd all have to have a super majority of people sign off on things to move it out of treasury. And then we don't fork, so if you're actually doing something like tokenized assets, or if you have difficult to manage data, you actually are responsible for all copies of that data that do exist. And so if you're building on a network that can fork, you could have a theoretically infinite amount of times or copies of your data, and you are legally responsible for managing that. So if you have something on Ethereum, you accidentally upload PII or something to it, there's a dozen forks of Ethereum, now you have a dozen copies of your user data to manage. That sounds fun. But yeah, so these are all really good reasons to pick to choose to build on Hedera. We already have over 500 companies, I think. It kind of changes. More and more coming every day, more and more getting onboarded constantly. That stretch, every market that's kind of out there. It's not just people in gaming, it's not just people in supply chain. We want everyone to be building on Hedera using these services. But to talk about what you can actually do as like an end business using these services, so Hedera's business is building these services and people paying HBARs for fees to use them. For other businesses that want to use these and build core infrastructure on the Hedera network, you can do things like payments. We can handle your 10,000 transactions a second. With cryptocurrency, you can actually do things like ad hoc business relationships. We actually put out a browser extension that's a great demonstration of this. You can pay people now without actually them having to know anything about you. Like right now, if you wanted to go to like a paywall or give the Wall Street Journal money, you'd have to go there, fill out all your billing information, give them your credit card, and pay them. With micropayments, you can actually just have your private key. You can add that to like a browser extension, and they can just deduct funds out of your browser extension. So it's a really transparent way to kind of disintermediate paywalls. So that's a nice way. But then there's also transparent fundraising, which I think is a really great use case for cryptocurrency. So the fact that you can actually track all funds going into a politician's account or going into a university's account, you can actually track all funds going out of it and see what they're being spent on. I think the public sector is going to eventually, given enough of a time scale, actually expect this kind of transparency across all accounting, where everything that a public business does has to be a public record. So it'll be interesting there. AdStacks is a great example of a company that's actively using Hedera's cryptocurrency service. They're doing something like over 200,000 transactions a day on the Hedera network. To give context, like Ethereum handles something like 600, 800,000. So we have one application doing about the fourth of the volume of the entire Ethereum blockchain. And basically what they're doing is decentralized advertising and provable advertising, and in real time paying all of the parties that are involved in advertising to reduce fraud and risk and all these good things. But they're working with some of the largest advertising and media companies in the world already, and so they're actually going to be radically scaling up that 200,000, and we're excited for them to kind of throw all the transactions that they want at Hedera. Next use case that we're excited about is credentials. And so credentials are basically ways that people can attest to facts about you. So your government or wherever you were born, that hospital has an attestation or a credential that says that you were born there. Your DMV probably has a credential or a record that says that you have a valid driver's license. And so you can use these different types of credentials in ways on a transparent network to do things like decentralized identity, where you could actually have a file or account on the Hedera network that have claims or attestations to these facts. And then you can use that information in a decentralized way to share that with other parties. So you could have an account on the Hedera network, or you could have a file on the Hedera network. You could have a KYC provider or a university come in and claim to that account and say that this is a KYC'd account. And then if I, as a business, said I only want to take business from people that have KYC, you could actually say, I accept these kinds of KYC providers. If your account doesn't have this type of claim on it, I'm not going to take your money. And so there's different ways that you can actually attest to the information that's on the ledger, and then other people can share that information to prove different attributes or things about themselves. And so being able to say something like in real time, does this person have their driver's license? Does this person have the ability to practice law in a country or practice medicine in a country? Is a really powerful business model. And if you think about the way credentialing currently works, it's a really slow and tedious process. Like if you want to go prove to someone that you have the degrees that you have, you're going to have to go somewhere, you're going to show up in person, you're going to fill out some paperwork, and especially if you're in like the medical field, like this could take months. And so being able to do this in real time on the ledger can cut that like months down to minutes. And so it's a really interesting business proposition. But we also have revocation management where people could revoke those claims. So if someone gives you a driver's license, they probably need some way to be able to say, I will revoke your driver's license if you no longer have the right to drive. And so Hedera enables all these things really well. And so MyEarthID is building a decentralized identity solution. Basically, you can add information or different identity attributes to your MyEarthID, and then you can use that or share that as kind of like a reputation system. So instead of sharing everyone your social security card, you can share them your MyEarthID that is basically an attestation to the fact that you do have a social security card there on file. So interesting business models there as well. And then the last use case that I'll talk about, and I'm almost out of slides, I promise, is tokenized assets. And so tokenized assets are just different ways to generate liquidity. So if you think about how hard it might be to sell $1 billion building or to sell large portions of companies, being able to actually break that down into 1 millionth or tiny tokens that represent that larger entity, and be able to move those without the friction or overhead of, well, who's going to buy $1 billion building all at once? Is a really interesting business model. Like you see things like, I guess it's not decentralized, but Rally Road now will let you buy like a portion of a car and things like that. So it's a really interesting value proposition that you really couldn't do before. Atomic swaps are interesting too. So now that you have these tokens and these different types of assets, you can actually change between them or exchange between markets that weren't liquid before. So if you want to exchange realty directly for like portions of cars, like you probably could do that. But like if you have to think about how many different steps you would have to go through in a traditional business environment to do that, you're probably not going to trade your car directly for like your holdings in a different type of market. And then so once you have tokenized assets, you can actually incorporate or do entirely decentralized organizations where the funds or kind of the balances or the account management from those organizations are all managed in a transparent way autonomously on the ledger. And so you can have things like people's actually equity and their salary coming out of these kinds of tokens on ledger, which is a really interesting business model as well.
This is something that other currencies can do too, right?
Yeah, so tokenized assets are really built on Solidity standards. So the fact that we run smart contracts, we run the same smart contracts that you can run on Ethereum, means that all the tokenized assets you're currently doing on Ethereum can run on us as well. So like MakerDAO is a great example of like a stable coin that's completely decentralized. You could actually just take that contract, put it on Hedera, and you have a Hedera version of Maker that'll run identically the same. And so Solidity does provide a lot of the standards for how smart contracts can be used to create tokenized assets. Is that? And DLA Piper is a governing council of ours who's actively working on actually building a tokenized asset real estate marketplace. This came basically from them having a bunch of large clients who had large real estate holdings and didn't have anywhere to sell them. So they literally are a law firm listening to feedback. People come to their lawyer saying like, hey, I have all this money and all these assets. I can't sell them anywhere though. Can you guys help us with this? And so they're actively building on Hedera, which is pretty exciting as well. But yeah, so if you want to learn more about what we're doing, I'll be here. Hopefully I didn't bore you too much. But yeah, so please reach out to me. It's just cooper@hedera.com or visit hedera.com. We have all of our documentation and all that stuff. You can get access to a testnet there. And yeah.
If you don't mind, we'll only
I took
hold
too
some
long.
questions. I think we're only going to have a fairly brief presentation by Lone Stars to give you a really good, real example of how they're going to apply the Hedera network. And then that'll give us a little bit of time at the end to ask some more questions, okay? So without further ado, I'd like to introduce Sam Ulrich, who's the CTO of Lone Star Data.
Hi, how's everyone doing tonight? Oh, that's a little loud. Down here works a little bit better. Well, hope everyone's not too tired. I know it's a little late. Appreciate y'all coming out. Does this just roll into the next one? No, it does not. Well, let's see if we can get this set up. I assume this isn't too rough. Sorry, I don't want to fish around on your computer, you know. It's like going through a woman's purse or something. Just not your preference. How's everyone's night going? Hey, quick show of hands. Who's a developer in the room? All right, we got a couple of y'all. All right, so pre-question, how many of you guys have ever done something and looked at it and gone, all right, I know that this is a security problem and all, but like, I'll worry about it later. Anyone ever do that? It's okay to admit it if you have. All right, well, I have, and a lot of the internet has, and we're going to roll into that. All right, so my name's Sam Ulrich. I'm the CTO at Lone Star Data, and we do distributed cybersecurity solutions for industrial automation or industrial control systems. So as you'll see, you know, there's me, there's Nathan, our CEO, and there's Caleb, our COO. We got him over here. We'll roll on through. What we do, we validate state variables. We provide immutable event logging options, and we provide end-to-end encryption. And we do this in the industrial control system space. So next point is why you care. And I don't necessarily know if this is going to roll through, but all right, yeah. So a little background on this. I'll pause this real quick. This is a generator, and it was done by Aurora team. Essentially, I'm sorry? Idaho Labs. And essentially the concept here is they got a remote terminal unit running the Modbus protocol, a little background information, and it hooks up to a programmable logic control. Essentially what that means is it accepts information from the internet and responds to it. So their point was this is vulnerable and someone can come in, poke around on it, and rip it to shreds without ever actually going to the site. And they wanted to make the point that, like I brought up earlier, as the industry grew rapidly, everyone just kind of looked at it and was like, hey, we don't really have time to secure everything. We need to grow faster than it would take to properly secure all this. And so you have a lot of infrastructure in the industrial control systems that got built out without proper security. So what you're going to see here is this thing's literally going to rip itself to shreds without ever having human interaction. We'll just skip ahead because we don't really need to see all of it. Right. Alright, then we're going to roll forward. You saw it initially get the hit. You see it start smoking, smokes more, and then you see a external view, right? No one was on site when this happens, right? This is all internet to a remote terminal unit. So it's a big problem when you really think about it. So that's kind of what we're doing here, and we want to address directly what we're doing. The point is we want to protect high-value assets, preventing work-related injuries and understanding the connected environment. So the point here basically is we enable these IoT devices out in the field that are interacting with actual things, be it a generator, be it an oil rig, and we're enabling them to be protected. We're enabling them to log the events in real time and trust that when they go back to look at them, they haven't been altered. And then we're also enabling you to get a full picture of what your actual internet connected environment is. A lot of these people deploy these, and a subdivision may know that they exist, but the entire company might not have a full understanding of what is out there, where it's at, and what it's doing. So we're trying to solve these problems. Ooh. And then why Hedera? As you saw, we just went through the whole proposal, and there's tons of advantages, but we picked out 4 major ones. First, it has really high throughput, which is a critical part to anything that you want to scale, especially if you want to take it to a production environment with enterprises. They have a lot of throughput. And they have state proofs, and this is actually a really critical thing because the state is actually mathematically proven. And that's really critical when you want to protect things like the speed at which a generator is rotating or the amount of water that can flow into a tank. You want to know that a proper private key that had the proper authorization signed the alteration to the state the last time, and that gives you the ability to trust that. They're, as far as I'm aware, the only distributed ledger that has truly proven state proofs. They have a strong team. Mance and Lehman, Dr. Baird, they have had prior businesses together that have prior exits together. You know that the relationship is good. You know that they know how to grow a business. They thought long and hard about how they're going to structure this, and that was something that really resonated with us. They took their time and they got it right. And then clear governance is the final thing. Like Cooper said, Vitalik can wake up one day in a funky mood and he's got a ton of influence. And that is something that some people may appreciate, some people may not. But if you want to take this to an enterprise environment, you have to worry about these things. And defining a large council with differing interests at least assumes that you're going to get different people with different mindsets and different special interests contributing to the discussion, which enables you to at least trust that this is more distributed and more protected. So that's actually kind of the end of it, but just to recap what we're doing, because I want to make sure we're perfectly clear about this. If you have a remote terminal unit or an IoT device out in the field, we provide a couple values to that. We provide encrypted communication, which protects against eavesdroppers. We provide protection against altering state variables, or maliciously altering state variables, like how fast this generator spins, how much water gets to go into this tank, all these different plethora of problems that actually affect real-world tangible assets. And then we also provide a full picture of the environment and events that occur in the environment. If the temperature spikes, you can trust that the temperature actually spiked and it wasn't just someone maliciously tampering with it. And that's an actually important thing. I don't know if you guys remember this, but a ton of fire alarms or sirens went off in Dallas a couple years ago, and it was just someone poking around. They just want to see if they could cause a bunch of havoc. And so no one could actually go back and prove whether there was a problem or not, because all they knew is that all of a sudden all the sirens in the city just start blasting off. So having immutably, or at least controllably immutable logs that indicate what happened, when it happened, gives you a better picture when you go back to look at what happened and how you can address that going forward.
Wouldn't this be a great application for the autonomous cars?
It would be. At the moment, we're focusing specifically on oil and gas because we see a clear vertical and we're getting a lot of appreciation in that market. But we're definitely looking in the future to expand it. And that is something that's going to become a problem, especially when you get into the aspect of full self-driving capabilities. So yes.
I'm so ignorant here, so please.
Go ahead.
You're creating a consensus. If in that situation with the motor, right? If the computer, let's say, was supposed to be the only thing that could give consensus, what in the computer is being shared in the consensus environment that's saying that I am truly this computer?
Okay, so to clarify the different parts of the chain of what's going to happen here. Okay. You have the remote terminal unit sitting in the field, right? And that's what actually accepts internal input from the internet, right? And then that interacts with the actual hardware that exists. Then you either have some gateway or you've built the gateway into your remote terminal unit that actually relays that to the outer internet from your local network. And then you have the internet, which in this case would actually be hooked up directly to the Hedera network, and that's where it's going to be validating against. Essentially, you have established on the Hedera network, let's use the generator speed, for example, amount of times this will rotate has been defined on the Hedera network, right? The only person that can change that is the person that has the proper key set that can sign a transaction and have the proper permissions to alter that. And that's essentially the basis for all cryptography, okay?
And when you say key set, is that like a login and a password?
No, it's like a literal like public and private key. Now we arbitrate.
But only on one machine, or?
So like it works like cryptography, right? If I encrypt a message to you, I encrypt it with your public key, you decrypt it with your private key. If I sign it, then I sign it with my private key, right? You can validate that with my public key. They're paired together, right? And so essentially the concept is, this is a basic principle of cryptography, but essentially if you authorize something with a signature, the only signature that is provable, or if you authorize it with your signature, right, the only key that can prove that is your own. It's essentially a way to fingerprint a certain key set.
Yeah, but what are you physically doing putting the key?
Oh, like the actual person? Yeah. That's a whole, oh sorry, I totally misunderstood where that was going.
Like, what are they typing a password?
Yeah, so that's actually done. Yeah, no, totally. Yeah, that's all abstracted up to a higher level. You know, people aren't actually wanting to carry around like a public and private key, so that's all abstracted to a higher level where actual people, engineers, technicians are going to be interacting with the dashboard that manages all of these different things. So yeah, it'd just be a
could a hacker get into that environment?
Yes, provided a certain set of occurrences happens. I mean, truth be told, for me to sit up here and tell you that this solves every single problem in the world would be absolutely ridiculous. There's fundamentally a risk in the sense that, I mean, if you go out sharing your password or whatever method you use to log in your phone, all these different things that can be used for multi-factor authentication. Yeah, someone can get in and, you know, they can go tamper around. But at a certain point, you have to trust that individuals are properly trained, and that's how they're going to handle it. Because at the end of the day, that's why these companies have the actual people level training of cybersecurity, because that's the main fault point. You can secure everything, and we do our best to secure the entire network and every interaction in between there. But if someone does something stupid, like actually goes out and like hands out their password and lets someone use their phone, you know, we can only do so much. The goal is essentially to increase the difficulty of malicious tampering to a degree where it's no longer reasonable for someone to try. And that's pretty much what everyone does. I mean, that's why cryptographic algorithms are measured at brute force time. Not because they're actually foolproof, but because it's like, all right, if it takes you 100 years of nonstop trying, no one's actually going to try. So that's what our goal is to increase the difficulty for a malicious tamper to occur. Did that help out? Cool. Any other questions? All right, well, you want to come back up and answer all the other questions? Awesome. Appreciate y'all coming out and listening, by the way.
Okay. Yeah, were there any other questions about Hedera and what we're doing? I'm happy to just casually talk to people too if you don't want me to be on stage anymore.
Yeah, no, I just wanted to ask you, since you were with Hedera, and there's been this blog competition between Eric Wall and you guys. There's a blog that debunk the blog and then debunk the blog.
Yeah.
I just wanted to, I mean, you obviously seem to understand the workings really well.
Yep.
So are you familiar with Eric Wall's blog?
Yes, I am familiar with for anyone who isn't aware, Eric Wall is like a Twitter influencer. He's a cryptocurrency researcher. I think he might have like 20,000 followers or something. But he posted a blog post that literally is titled Hedera, or it's like time for some FUD or something like that. So.
Why would he come out with this article just before the mainnet opened up? Why wouldn't he have done that half a year ago?
I think that that's consistent with his historical interactions with other projects. I don't think that Hedera or anything we're doing is special in that regard. I think that's just what he enjoys doing. But to comment on the technicalities, a lot of it was arguing that we aren't as efficient as we are. So the fact that we can handle 10,000 transactions a second, by his definition, does not mean that Hedera is more scalable, which is a weird definition. I think that we address his criticisms pretty well in our response back to him.
I saw that the H-bar supply went up about just 3x in about the last 30 days. How does what is the supply timeline for H-bar?
We have a paper on Hedera.com about it.
I should look it up.
Just go to /hbar. It'll tell you what the distribution model and all that stuff is. Our network wasn't alive 30 days ago. We launched September 16th. So that was the first day that anyone could publicly trade or use HBAR.
Yeah, it was like 2 weeks ago. I was like just looking at the chart. I was just
Okay. Yeah, there has been some confusion around our actual circulating supply metrics. I know some exchanges have different figures. Happy to talk to you about it afterwards, but it should be on our website.
Does Hedera have information in regards to the authentication process and location of, like, let's say their consensus thing? Jim has to put his consensus in to turn on the engine and change the whatever. Like,
Is there any geographic attributes to our transactions?
Do you guys know where they are?
No.
IP address?
No. I mean, you can just use any type of VPN or traditional routing service to submit your transactions if you want. It's just like any other internet protocol.
Okay.
Does that answer your question? Like, if you're using Tor, like your routing is pretty heavily blocked. It would give you, like, submitting your transactions through a Tor-based browser to Hedera would give you the same security.
But do you know where do you know where the engine is? I guess where is that also?
So the engine would just be one client that's reading from the state of the Hedera network. So it would just be like any other browser. That engine could be using any type of security or firewalls, proxies, routing protocols. They could be running Tor on that computer itself too. So that's not really a Hedera question. That's like kind of the next step up. Like that's like an application question. Hedera is just like all other kind of internet protocols where you can use it however you want. If you want to have private routing, you can use private routing. If you don't care, you don't care. But it's just like using the web.
Okay, I have a question about the coin release, and Sam actually already answered it for me beforehand, but I just want to see if you have like the same thoughts here.
Yeah.
So I'm wondering, with such tiny transaction fees and with all of these coins that need to be distributed, why is it that the SAFT holders are receiving things in large chunks when it could be like, because every time a huge chunk like the other day goes out, it's like the price is going to kind of dip because it's almost like they're in a race to like be the first one to sell right before there's like a dip. So anyway, why wouldn't it be like however much you're going to get, you just get it on a distribution that's like once an hour almost, like you like divide out the distribution so that the coins are always being distributed?
It's a good question. I'm not an economist. I don't know what is better for markets, whether like slow, gradual inflation versus quick deflation. I don't know whether you're talking about monetary supply or the actual price of it is better for it. I do know that we have said that we've acknowledged the concerns from our SAF3 investors and are actively working on reevaluating or rethinking our token economics and our distribution model. There's a blog post on our website that it talks about it. We're also actively working with the Prism Group, which is one of the leading cryptocurrency economic think tanks or organizations out there who are really, really legit PhD economists that have deep expertise in this. And so we're actively reevaluating it at the moment. And so we are hearing people's feedback and concerns there. But I don't have the answers, I'm sorry. Yeah.
One other question here. The last few weeks there was a lot of talk about quantum computing.
Sure.
And Google got out with a new quantum computer. And obviously a lot of the crypto specialists felt that was a real danger for the entire crypto world.
Yep.
And quantum computing, taken it to the maximum, could eliminate basically pretty much all of the good crypto work done with cryptocurrencies and blockchains.
It's an interesting take.
What do you think about that?
I think post-quantum signatures, to how we understand them, already exist. It's just a matter of using them and them being efficient enough to be practical. But if you're asking if quantum computing is going to break all encryption, I would say definitely not. No one actually thinks that. They're just going to make the current encryption algorithms that we're using not secure enough, and so we'll have to move to other ones. But there's thousands and thousands of brilliant people working on post-quantum research. Hedera is kind of architected with flexible signature schemes, so once We are concerned about quantum encryption and quantum computers. We can support post-quantum signatures for people who do want them. They might be slower, but we will add support for post-quantum signatures when the governing council, like we said, they make all the important decisions, feels like this is an adequate concern. Is that what you were looking for? Yeah, I mean, so anyone saying that we're not going to be able to make post-quantum resistant algorithms just doesn't know. We'll see when we get there. Yeah.
So,
thank you for organizing, by the way.
What's that?
Thank you for organizing, by the way.
Yeah, no worries. I'm glad everybody can figure it out. Two of the primary purposes of the consensus algorithm is to determine the order of events and the timing
Yep.
of those events, the timestamp. I mean, currently we kind of vote on the timing, average out the timing, but none of the computers are accurate,
Yep.
right? So it's really a relative. They all have error, and we're just getting a timestamp that's, the average of all the erroneous timestamps, right?
Sure.
Have you run into any applications that require better than that require a more absolute reference to real time?
That's a good question. I guess it depends how you define absolute, maybe. Because at some point, once that transaction on Hedera does achieve finality, we will give you one timestamp. That is the average time that it reached a supermajority of the network. And so there is only one timestamp on Hedera that you have to concern yourself or worry about that's going to be in your transaction receipt. And so you can use that as a single source of truth. It's never going to conflict, and it'll be the fair timestamp that you're looking for. If the aggregate and average time that it reaches the supermajority of the network isn't what you're looking for, like if you're not looking for the source of truth from the network, but you're looking for the source of truth from the world, you could do things on Hedera where you have a smart contract. That smart contract calls an oracle, and so anytime that you submit this file update, you could actually encrypt the time from some other service and use that as the memo, or use that as the data going into your smart contract. So if you really wanted to, you could go get the current time from somewhere else, encrypt or put that data in your your cryptocurrency transaction, right? And so that way you have your own relative source of truth, this is when I submitted the transaction, I put this timestamp in there, and then you'd also have the secondary timestamp of when it actually had consensus achieved on the Hedera network. So that would give you the relative state, or the relative timestamp from Hedera, but it would also give you your own personal sense of truth from whatever you want to put in that message.
I guess I'm thinking of a scenario down the road as this scales out, where in North America people are either using GPS reference or MTP servers or whatnot, and in another country they're using Galileo or nothing else, and we start to diverge in terms of time base. And then does that create a advantage or disadvantage from a timing perspective? So it seems to me that it might be an area for further research and improving the algorithm.
Yeah, absolutely. Lehman is much smarter than I am, and I'm sure he's much more concerned about different types of time differentiations and time floats and how we deal with, especially as we add more nodes, the different variations in that timestamp. But the nice thing is that Hedera and Hashgraph will always give you that one source of truth, that even if those people in Africa have a terrible internet connection and people in North Korea want to exchange, they're not going to be seeing a different timestamp, But yeah, no, there's definitely worth doing some research into kind of standards of how you would do a global source of truth and the Hedera timestamp and ways that those are used together to validate things.
Is that timestamp as precise as would be needed, for instance, in machine trading?
So.
You have split seconds.
So yeah, if you want to do high frequency trading, it doesn't really make sense. I personally don't think it makes a lot of sense to use a decentralized system. You don't really need the security or the trust model that a distributed network is giving you if all you're trying to do is buy stuff from the New York Stock Exchange. You can set up and use their APIs directly, and you don't really need to go to another network to use them. But I mean, you could build decentralized fair exchanges where they're peer-to-peer protocols entirely on the ledger, where you don't go to the stock exchange. And then at some point, maybe that relative timestamp could come into play, where it's I thought I submitted this then, it reached the network 4 seconds later, or there was a network partition and I wasn't even able to submit it at all.
It comes up in this.
I mean, it's accurate to Milla.
In these cases, it comes up the machine trading and also video games, where
Yeah,
You
well,
have to find out exactly who shot first.
yeah. Well, it's accurate to milli and nanoseconds, and we can totally do that. Like, if you're only worried about two parties saying who shot first, like those milliseconds are not going to conflict with each other. Like the probability of two people actually hitting that button and it propagating through the network and that transaction getting submitted at exactly the same time is very unlikely. But they.
Why does it even come up in the use cases?
Why do you need that fair timestamp?
Why does it come up? Hedera talks about that.
Yeah, so that's actually kind of one of the fundamental underpinnings of how Hashgraph works. So the order of those transactions in Hashgraph is determined by those timestamps. So basically we can basically get all the nodes in the network. We can basically say when every single node in the network saw this transaction. And based off how much stake that computer has, we can actually put them in orders based off the influence of those computers and those times. So the timestamps is actually basically one of the mechanisms that Hedera uses to guarantee this order. So basically we'll take all the timestamps, we'll take the median timestamp, and then we'll put them in the order based off that median timestamp. And so it's intrinsic to how the protocol works, but then you can also use those timestamps for things like if you need to prove that your document was submitted by midnight, but their website was down. You could submit it at 11:58 and then send them a hash that's like the hash of that document or whatever you were doing and say, hey, your website was down, but here it is. So it's a provable timestamp as well, but it's intrinsic to how that consensus mechanism works. There's no stupid questions. No one. This market's only been around for like 10 years. No one knows anything.
Okay. So does Hedera? So you don't know the location, but do you know some maybe dummy? Do you know what transaction? Do you know that a transaction is taking place? So
That's kind of the point. Is everyone knows every transaction.
You know every transaction. So my question is, aren't you like a centralized source of like every piece of information and contract going on?
In the same way that the Ethereum blockchain is the source of truth for everything going on in Ethereum, yes. Like Hedera is the source of truth for everything going on in this network.
The actual information, like if you wanted to put like a mind map of like everyone's activities.
Yeah. If you had like a Batman-esque cave and like could map everything.
Yeah, and you could say like,
Yeah, there's companies actively doing this. Like Chain Analysis is doing this as a service.
that's public information.
Every transaction on a public network is public information. That's one of the key value propositions, is that it's transparent and audible and everyone can prove that this transaction actually took place. You don't need to trust any individual person. You can actually go to different parties and say, hey, did this transaction happen? And they all have like an equal ability to prove to you that that happened. It's not just up to one person. Does that make sense?
No.
Okay.
Maybe I'm asking the wrong thing.
No, we can talk about it more afterwards. Happy to explain like why it's beneficial to have that transparency. But one of the whole things is that everyone can see everything, and that's the kind of the value proposition. And once you have everyone seeing everything, you need to have the cryptography and the ways to prove that it's the right data and that it's not being tampered with, and that's where the crypto comes in. Yeah.
Are there going to be privacy features implemented in the Hedera? That's kind of a big thing that's happening on other.
Yeah, it's a good question. So we're not actively working on anything like zero knowledge base, or if you're looking into that space. The consensus service is one way that we do enable privacy-like features where you actually could encrypt all your messages going on with the consensus service. And then you could actually have like a fabric deployment or like a private database even that's on the other side reading from this encrypted message queue and then decrypting on the other end. So you could still have the transparent auditability of the Hedera network, but you could actually have the data that people care about on the end of those transactions be totally private. So we do enable this kind of private business model. Hedera is not actively working at the moment on anything like zero knowledge or private based, like relative to the state of Hashgraph. Is that what you were looking for?
Yeah.
Yeah. We're not a privacy focused thing. We're focusing on enterprises and scalability and security and governance and all these things.
So Cooper, piggybacking on that question, what's the timeline for enabling anonymous nodes, for example?
It's a good question. I think it could, so the timeline for anonymous nodes is also in coordination with how sufficiently distributed HBAR is. Like if HBAR isn't wide enough distributed, those nodes aren't going to have enough HBAR to meaningfully actually use in the network, because so much of them are in Treasury, the Treasury is going to have a controlling amount of stake anyways. So it's really pointless to allow anonymous nodes until then. Anyone can run a mirror node and you can get all the information anyways, but you want to be able to actually affect consensus. So once HBAR is sufficiently distributed and enough of it's out in the market, that's when we will start enabling these alternative type of nodes. Before we enable anonymous nodes, though, we're going to enable like trusted business entities, known companies in the space, things like that. So there'll be, I want to say there's like 3 phases. Lehman has an amazing webinar. Go to YouTube. It's called The Hedera Path to Decentralization. It's like a great video where he outlines like why we're doing this, why it's conservative, and basically our whole distribution model and why we're not letting people currently run anonymous nodes is enable to basically ensure the stability of the platform in the early days, where like if someone did want to invest a lot of money building on us, we need to know that for the next year or so that this is going to be a stable environment. But yeah, no timelines, unfortunately. But.
Well, we have the room until 8 p.m. But I'm sure some of you have some questions and might want to have some conversations amongst yourselves. So feel free to grab whatever beer and soda might be left and talk amongst yourselves. Thank you very much to our guest speakers. Thank you. Thanks. Yeah.
We got so we want to we're going to set up like a full blown demo, just let Ryan let customers come by and take it down. So I want to see. I'm totally down to take you for all the shit. We get something set up with this stuff, throw your name up there and everything. And like I know you're doing Python, so I'm trying to see a fair amount of this in Python.
I mean, what they
the way it works, right? Hyperledger is it's like Hyperledger. If you mention cars, Hashgraph is offering to sell a freight motor, and then Hyperledger is happy to sell the shell, the chassis, So Hedera itself is Hedera itself is like Mercedes selling the whole car, like Chevy selling the whole Camaro, and then like what they're offering to do is like buy like the LSP and dropping by the way, I'm Sam. I'm a fisherman. Oh, really? Oh, okay. Yeah, okay. Yeah, absolutely. Yeah, okay, now I remember. Sorry, that was a 5 or 6 months ago. But yeah, drove down. Oh, really? Live. You should come down there. One thing after Get my number. I'm gonna grab my
Because it almost, I get